Hello, in this lab we're going to start the motor we've been using for the other labs with the high inertia load with a auto transformer starter. So this is the circuit we're going to use. This circuit is on Learning Hub, so if you want to print it out and follow along, might be a good idea. What we have is we have a auto transformer. It's got a 50%, 65, and 80% tap. Now we can either use the 65 or the 80, it would be common. 50%, not going to get much torque, wouldn't be a good idea to use that. We've got a control power transformer where we apply 208 to the transformer and we get 120 volts. We're grounding the common. We've got a fuse, we've got a standard stop-start circuit, and we've got 3 contactors. We've got 2S, 1S, and R. 1S and R are mechanically interlocked and electrically interlocked. And we've got a timer relay that has both instantaneous contacts. So we've got the 1TR normally open instantaneous contact and 2 timed contact. We have the normally closed timed open, and we've got the normally open timed closed contact here. So the sequence of operation, when we hit the start button, TR energizes, and at the same time, the normally closed timed open contact will remain closed until TR times out. Therefore, 1S energizes, and you can see here 1S contacts close, and that creates a Y point on the auto transformer. At the same time of 1S closing, we've got the 1S auxiliary contact with it, which energizes 2S. When 2S energizes, the 2S auxiliary contact seals itself in, so it does not rely on anything else to stay energized. 2S will stay energized the whole time, and that's very important to understand how this works as a closed transition starter, or also known as the Korndorfer circuit. So 1S closes, 2S closes. When 2S closes, that applies 208 volts in a Y connection, line to line. So we're going to get about 120 volts on each full winding from 0 to 100%. And the motor, you can see it's connected to the 65% tap. So it's going to have applied 65% of 120, which will give us a line-to-line voltage of 65% of the 208 volts. So we'll have about 130 volts line-to-line. So the timer's timing out. We've connected about 65% of the voltage. Once the timer times out, there's 3 things that happen in sequence. TR time contacts. This one opens, this one closes. So the first in the sequence is 1S drops out. When 1S drops out, R energizes. Remember, this opens, this one closes, but this must drop out before R energizes. So R energizes and closes the R contacts. Now if we look up here, remember 2S does not get connected. So this whole time, the motor is still connected to this part of the winding when this drops out. So when R energizes, that basically just bypasses the line from here to the motor. So we apply 208 volts. 2S stays energized, but because it's basically shorting out from here to here, this is open, there's no voltage across here anymore. So the motor will get up to full speed, the current should jump up, and then it should accelerate, and it will settle at its full load current, or whatever current is needed to maintain the speed of the motor. When I hit the stop button, everything drops out. There's a couple other features in this circuit. We've got this RB normally closed. That is a temperature sensor in the core of the transformer. If the transformer gets too hot, it will not allow you to start. You can see it's in series with these coils. We've got our overload contact here. The reason we need the temperature switch is these, it's a relatively small transformer, and it's not designed for continuous starting and stopping. Its duty cycle is low.
Okay, here we go.